This is a discussion of the t-test used to test a value against an initial hypothesis, and particularly deals with the material that is discussed relative to figure 9.3. In this spreadsheet, I have shown a null hypothesis that the mean value for costs of a hospital stay or costs of hospital stays is $6,000, and the alternative hypothesis is that it is not $6,000. I've drawn one sample from a population of hospital admissions to test the null hypothesis, and the sample has yielded a mean value of $6,586.30 with a standard deviation of $5,262.73. And the standard error for a sample of size 100, which is the sample that I drew, is $526.27. On the right in this chart, I've shown essentially a t-distribution. A t-distribution is centered on 0 and goes out on both sides of 0, essentially to infinity, but for practical purposes, not really beyond plus or minus 4. 95% of all t-values are essentially within two standard deviations, minus 2 to plus 2, on either side of the central point of 0, and approximately 99% are within minus 3 and plus 3. If the true mean for the population from which this sample that yielded a mean value of $6,586 were actually $6,000, and I drew a very large number of samples from that population, and then I calculated the t-test, which is actually calculated right here and is given on page 276 as 9.1. Approximately 95% of all of the t-values I got, and this is one of those t-values, would lie between minus 2 and plus 2, and 99% approximately would be between minus 3 and plus 3. With a sample of size 100 and 99 degrees of freedom, the actual limits would be 1.98 above 0 and 1.98 below 0. So where would be those limits? Well, I've got some red lines here, and I'll put them approximately where the limit, the upper and lower limits are. Those represent essentially the 95% confidence limits, approximately 1.98 units above and below 0. Where is the t-value that we calculated? The t-value we calculated from this information using the formula on 276 9.1 is 1.11, and it would be approximately here. Because the t-value we calculated lies between the two sets of red lines, we would conclude that we cannot reject our initial hypothesis, even though the sample value we got was 6,586. It's within the two standard deviation limits, or 1.98 standard deviation limits, for a two-tailed test, which is what mu not equal to 6,000 means. Suppose, however, instead of getting 6,586, we had gotten 7,352. In that case, our t-value is 2.56, and our blue line would be someplace here. Now, since the blue line is outside the red line limits, we would reject the null hypothesis in favor of the alternative, which is that the true population mean is not equal to 6,000.